Okay, this lesson is about finding missing angles that happen to be labeled inside of parallel lines cut by a transversal. So the first thing we're going to do is we're going to take a look at these angles that are given to us. If you trace both sides of the angle where the algebraic expression is listed, it'll hopefully give you a visual and you'll be able to tell what type of angles you're dealing with. These are called corresponding angles. We learned that corresponding angles can slide down the transversal. They're going to have the same measure. So our job is to go ahead and find the measure based on what we know. We know that this algebraic expression is going to be equal to this one based on the fact that those are corresponding and they have the same measure by definition. So remember, when you have an equation like this to solve, there are variables on both sides, so you're going to move the smaller variable. This gives us a two-step equation that I know you are comfortable solving. And if I do the last step correctly, divide by 6. I think we have a mistake here somewhere. I lost the 1 on my 61. Be careful, guys. Alright, that's better. 103 minus 61 is 42. There we go. So now when we divide, we do not get an answer that is awful to deal with. We get x equals 7. Okay, we're not quite done with the problem, and here's why. They really want the measure of the marked angle. So remember how we use this expression. If we now know the value of x is 7, you're going to take 9 times the value of x plus 61. So 9 times 7 plus 61 is, I got 124 degrees. Do the same idea down here with this expression. 3 times 7 plus 103. Surprise, surprise, we get the same angle measure, but you should. Corresponding angles have the same angle measure. So that's one way to check your work. If both expressions gives you the same value, then you're doing the math correctly. Now, not all angular relationships have equal measures. If you take a look at this second example, it talks about the table and how the table is parallel to the floor. And I really like paying attention to this set of angles right here. Unfortunately, they gave us the 4x, but they did not give you this. So one thing that helps is labeling that. The other angle you can see that they have listed is next to that. Okay, these two angles would not only be called adjacent angles, but because they add up to 180, they are going to be supplementary. So this equation is going to take up a little more room. We have to say that this one, that looks like it's going to have a measure that's obtuse, more than 90, we have to say that this angle plus the 4x is going to equal 180. So your solving is a little bit different. You need to combine your like terms. I have no idea where that number 47 just came from. Sorry about that. It's supposed to be a 4x. Why it looked like a 47 to me, I do not know. So now I think we're okay. This time you're going to combine these like terms, so that does give you 21 x's. And we can move our 9. $189 divided by 21 is going to be our last step. So I think I have this completed on my next slide. There it is. X equals 9. And then remember, the ultimate answer to this question is that we found the measure of each marked angle. So again, if x equals 9, we can plug 9 into our expression. 17 times 9 minus 9, I get 144. 4 times x, I get 36. Okay, this time, remember, we're not expecting them to be the same measure because of what we found when we first looked at the problem. Together, they should add up to 180. If these add up to 180, that is a way to check your work. Now what you have on this side of the page are some practice problems. The first set of angles is not corresponding, even though some people think it might be. You could kind of do some labeling with this alternate interior piece here. This 3x plus 7 would match this angle on this side, if you can kind of see how they're both little acute angles. Sometimes it helps to rewrite this next to the other one, and then it helps to see, hey, they do form a 180, a half circle together. So if you can tell what kind of relationship the two angles have, in this case they're supplementary, you have an equation. Go ahead and solve the equation. And if you want to set this one up as well, then I can give you some work time. This is an example of some angles that are also supplementary. And the reason they are supplementary, let's see, if we redraw this one down here, okay, this spot along with this spot over here at the top, they are called alternate exterior, and they will have the same measure, but the angles that they want you to look at are these two. So these two are going to be supplementary. They form a half circle together. So again, this stuff adds up to equal 180. This is where you can go ahead and hit pause, solve the problem, and then come back and check your work. Okay, if you combine like terms and then you started solving, excuse me, you should get x equals 12. Plugging 12 in, 3 times 12 plus 7 gave you the angle of 43 degrees. And then the larger angle, see how wide open it is? It's supposed to be obtuse. 10 times our value of x plus 17 should give 137. The other angle that we set up, remember, you're going to combine like terms again, and you're going to solve. This time we get x equals 11. And again, plugging in 11, we have our 7 times 11 minus 9. I believe that one's the one that's 68. And the one that is more obtuse, right, measures more than 90, would be the 11 times our x value of 11 minus 9. So these two angles add up to 180, these two angles up to 180, and that's one way to check our work on the problem. So guys, we're going to go back on the bottom of your note sheet. There are two more practice problems. The deal with these two is these angles turn out to be perfectly congruent. This forms the Z shape that we talked about being alternate interior, and alternate interior angles are equal, remember. So your job is to take this expression equal to this one. You can see how your equal sign is in the middle this time. And you will use a very different strategy, remember, to solve these. And then while we're here, let's set up the other one together. And then again, you can pause the video to do the practice. These are called alternate exterior. Okay, alternate exterior angles are also congruent. So that's why you're setting this one equal to this one. Again, the locker is right down the middle. And make sure you use the proper strategy to solve. Go ahead and hit pause while you try this, and then hit play to check your work. Okay, remember your strategy for this kind is to move the term that is smaller. Negative 8x is definitely smaller than negative 6x. That's why you want to add 8x to both sides. At this point, you want to subtract your number because you want x's on one side, numbers on the other. And then at the very end, it's strange here because we do get a negative x value. But it works out because when you plug in that negative x value to your expression, you already had a negative 8 times x. So this, remember, negative times a negative turns positive, and you end up with 56 degrees. And then for this one, we had to take our negative 6 times the x value of negative 6 plus 20. So guys, on the bottom here, remember, these angles are supposed to have the same measure because of the alternate interior and the alternate exterior. On this side, move to 5x, move the numbers, divide, nice answer of x equals 15, and then of course make sure you plug in your 15 for both expressions. If x is 15, we multiply, get 81. Again, if x is 15, you're going to multiply, add 6, and again, hopefully get 81. So, your notes get cut, taped into your notebook, page 7778.